Good afternoon. Now we will see question number 4, which was asked in Insem examination. So we have question number 4. What are the parameters that affect design compression members, design strength of compression members? Now see, if we will see the formula, then we have formula for PD, that is design strength, is AE into FCD. So first factor we have, that is member classification, which is from table 2. Member classification. This relate with your AE. Then we have second, buckling class. Because buckling class will decide your table 9 A, B, C, D. So that is second, buckling class of section. Then we have third, yield stress of material. Yield stress of material. Because again, it may affect your value of FCD, because if you will go to table 9 A, B, C, D, then your FCD value depends upon yield stress of material, that is Fy. Then we have, that is fourth, connection, because connection of the joint will decide your value of K, because if you have bolted connection we have value of K 0.85, and if it is welded then we have value of K, that is 0.7. Then we can have fifth, that is connected leg, because connected leg will decide your minimum value is of RZZ or RYY. So we can have again points in this, that is you have single angle section or double angle section, that also affects your strength. So you have 1 marks for your one parameter. So likewise you have to mention these parameters. Now we have second, that is a column of 8 meter long consists of two ISMC 350 at 42.1 kg per meter placed back to back. Now these are again effectively held in position, but not restrained against rotation. So we have to find economical spacing between channels and design strength. So we will go first, that is what are properties of this section. So we have properties A5400 of single channel. Then we have RZZ 136. 136 millimeter, RYY 28.2, CYY 24.4. So now we will go first, that is step 1, economical spacing. Economical spacing. We have formula for economical spacing, that is RZZ whole equal to root of RYY individual square plus H square. What is H? H equal to CYY plus S by 2. So if we will draw the channels, then back to back, so we are somewhat like this. So we have y axis individual over here. This is y individual. And then y whole we have inside. This is y whole. And the distance between two is h. So we have this as cyy and we have this distance is s. So automatically this becomes s by 2. And so we will get distance between the individual and whole axis is h, which is cyy plus s by 2. Now we have RZZ 28.2 square, sorry, 136, which is equal to root of RYY individual, we have 28.2 square plus H square. And when we will solve this, we will get value of H 133.04 millimeter. 133.04, which is equal to CYY plus S by 2. Now CYY we have 24.4, and if we will solve this for S, then we will get S equal to 209.68 millimeters. And therefore provide S equal to 210 millimeters. Now we will go for second design compressive strength. So we have to go straight to classification. Then we have B by TF. So B we have BF by 2 by TF. We have BF 100 upon 3.2. 13.2, 13.5, which is equal to 7.41, less than 9.4. Therefore, flange is plastic. Flange is plastic. Now, second, we have D by TW. So, this is capital D minus 2TF upon TW equal to, we have 350 minus 2 into 13.5 divided by 8.3, which is equal to 38.91, less than 42. Now here we have wave is semi-compact, because for all we have same value, we have to go for lesser class, and therefore section is semi-compact. Section is semi-compact. So we have next step 3, effective area. Effective area, and then we have effective area, that is AE equal to AG, and that is equal to 2 into, we have 5400, which will be 10800 mm square. Now we have step 3, design compressive stress. But step 4, design compressive stress. So we have first KL upon R. Now KL we have 1 because we have both ends as hinged, because restraint against position but not rotation. So we have value of L effective equal to L, and therefore we have 1 into 8,000. R minimum we have, that is RZZ, which is 136 gives us value 58.82. Then we have value 50 and 60, which is KL upon R. Against FCD, we have 183, 168. And we can find from this FCD that is equal to 183 minus 183 minus 168 divided by difference of 210 in bracket 58.82 minus 50. And from this we will get value of FCD 169.77 Newton per mm square. And then we have step 5, design compressive strength. Design compressive strength. PD equal to AE into FCD. AE we have 10800 into 169.77, and we will get value of PD 1832.87 into 10 raised to 3 Newton, and therefore design compressive strength of column is 1832.87 kilonewton. So likewise, we have to find the strength of the column. So now we will stop here only. Thank you.